Linear equations can be written in three different forms: general form, slope y-intercept form, and slope point form. It's really important to be able to know how to convert between the three of them and when to use each. Here I go through it all. The big thing about linear equations is you got to know the different forms. We've got the general form here. It looks like this. It's ax plus by plus c equals 0. You've got the slope y-intercept form, y equals mx plus b. And then you've got this slope point form here, and it's y minus y1 equals mx minus x1, and it's right there. We use these for different purposes. The slope y-intercept form is used when we're given a slope, and the y-intercept makes that one easy. The slope point form is used when you've got the slope and any point on a line. A lot of times you have to convert between them. It's not that hard. I've got a couple exercises to show you how it is. Imagine you were given this exercise here. You got point P, which is 3, -1, and point Q, which is -2, -6. You've been asked to determine the equation in general form of a line passing through these 2 points. All right, well, you can give it a go on your own, but I'm just going to go through this. First thing you want to do is find your slope. We call the slope M, and this is MPQ. We take this value and we subtract this one. We take this and subtract that. That's how you find your slope. It ends up looking like this: -6 plus 1, -2 minus 3. And we have that plus 1 because we're subtracting a negative. It equals -5 over -5. We've got two negatives here. That means it's going to be positive. Our slope is 1. Now we can use y minus y1 equals mx minus x1. That is the slope point form. And what we're going to do is we're going to put in one of the points. Let's take this point right here, point P. We're going to put it in where we have the y1. So we're going to say y minus a minus 1. That's going to be y plus 1 equals 1. And then we've got an x minus, and then the other point, which is 3, so we're going to subtract 3. We've got this 1 here because it is the slope. All we have to do is put this in general form. So what we need to do is multiply out what's going on here and put everything on one side of the equal sign. So this will end up being y plus 1 equals 1x minus 3. What we want to do is put everything on the equal sign, so we're going to get this y plus 1, and we're going to subtract a y, and we're going to subtract a 1 from both sides. That's going to equal us 0. So now we have x minus y minus 4 equals 0. X minus y minus 4 equals 0. And we are done. We've got it in our general form. Here's another question. Now, we want to determine the equation in general form of a line through point 50 and perpendicular to the line with the equation 3x minus 5 plus 17 equals 0. Well, the first thing you want to do is you want to take this and you're going to put it in y equals mx plus b form. So let's take it. We got 3x plus 17 equals 5y. We're going to divide everything by 5. These will cancel out, and we've got y equals 3 over 5x plus 17 over 5. I see that my slope here is 3 over 5, so the perpendicular slope would be the negative reciprocal of that. So that's going to be -5 over 3. What we're going to do is we're going to use our slope point form again. We've got our y minus y1 equals mx minus x1. Now we're going to plug in our point. We've got this point 50, and we've got this perpendicular slope of -5 over 3. So we got y minus 0 equals -5 over 3x minus 5. We're going to multiply both sides by 3 to get rid of this 3 down here. That gives me 3y minus 0 equals -5x plus 25. So we've got 3y equals -5x plus 25. We want to put everything on one side of the equal sign, so we're going to put everything over here. So we have a negative here. When we have it on the other side of the equal sign, it's going to be a positive. That's 5x plus 3y. And we've got this 25 here. We're putting it on the other side, so it's going to be a negative 25. And that equals 0. And then finally, we've got one more equation here. Once again, we're asked to put it in general form. We've got a line perpendicular to this line in general form with the same x-intercept as this one right here. We're going to start out by finding the slope to this line right here. We write out our equation. It's in general form right now, and we want to make it into slope y-intercept form. So what we do is the first thing, we're going to put our y onto this side. So it's going to be a 7y equals 5x minus 10. We're going to divide everything by 7 so that we can isolate that y. Now that means that y equals 5x over 7 minus 10 over 7. We're not really interested in this, but we are interested in this. So the perpendicular slope is going to be the negative reciprocal of that. And so that's going to be negative 7 over 5. Now we're going to take a look at this other general form equation. It's right here, and it says that we want to find the same x-intercept as that equation, not the y-intercept. So our slope y-intercept form, it's not going to help us here. But one thing we do know is that if it's an x-intercept, that means that y equals 0. In this equation, x minus 2 and y equals 0, so we just put in a 0 for y, minus 12, and that equals 0. This cancels out, so we have x minus 12 equals 0. We add 12 to both sides, so that means that x equals 12. So now we have a point. We have where y equals 0 and x equals 12, and that's that x-intercept. So what we use is slope point form. Here's our slope point form. Y minus y1 equals mx minus x1. All right, we're going to put in this point right here. So it's going to be y minus 0 equals negative 7 over 5 x minus, and then we have this point 12. Well, what we have to do is we have to multiply everything by 5 to get rid of this 5 in the denominator. So now we have 5y here, and this equals, this is going to be negative 7x plus 84. All we have to do is take that and put everything on one side of the equal sign. So we have 7x plus 5y minus 84 equals 0, and we are done. So I hope that you've learned something about these three linear equation forms. Thanks a lot for watching.